Hello everyone. So in this video, I want to talk about functions. We're going to describe what a function is and see how it allows us to repeat instructions that come up more than once in our program without having to copy paste them over and over and over again. We'll look at a couple features of functions like parameters and returns and see how we can use the hundreds of built-in functions that come with Python. So to get us started, the motivation behind functions is that sometimes we write this really good little bit of code. We get some sequence of instructions that we want to do again and again and again. This could be something like a nicely formatted print statement, like a main menu in your program. It could be a complex mathematical operation, like taking a square root or a cosine. But whatever it is, it's something that you end up wanting to use again and again. So the simplest thing that we could do in a case like this would be literally take all of our instructions that implement whatever behavior we want and just copy paste them into every file where we need to do that thing. Every place where that procedure repeats, we just put another copy of all of those lines, whatever 10, 100, 1,000 lines of code we have that does what we want to do, just copy paste it and the computer will do it again. So we could do that, but the problem with that is once we copy it, we no longer connect those two copies together. Let's say in the future I find out there was a mistake. I went to take the average of two numbers, let's say, in my instructions, and I found out, oh, well, my average is always off by 1. If I have the same one, I did the math wrong. Well, if I copy pasted these instructions into this file and that file and that file, then in order to fix it, I have to go open up this file and that file and that file. And normally we don't even have a list of all the places that we copy pasted something. So we could very easily forget to update one or make a typo when we're doing the fix for the 5th time in a row. And so we really don't like to do copy pasting as programmers. There is sort of a saying that all programmers live by, which is don't repeat yourself. If you've written your instructions nicely once, then your goal as a programmer is to have there be that one canonical copy of your instructions, the one place that you've written it, and then find some way to reference that everywhere else so that if we want to change it in the future, we can do so by just updating that one copy that exists. So the tool that we have to do this is what's called a function. So a function is just a sequence of instructions, just like our little example of whatever code we want to repeat. But this group, we indent it, we give it a name, and then in the future, we're able to call it by that name in order to use those instructions again. And now, there are a lot of details in how we can use functions, but the big idea, the big goal of this tool is that we want to be able to just write functions once in a single place and then call them everywhere else by putting that name that we've given them and a pair of parentheses, any place that we could write a normal expression. So in order to write one of these functions, we do need to add a little bit of extra syntax for our program. In order to tell Python that we're writing a function, the first thing that we do is put this special keyword def, D-E-F. That's short for define. But what it says is, hey, everything that comes after this is part of my group of instructions that I'm creating. So we start with that def keyword. And then the next thing we have to do is give our function a name. So let's say I had my main menu function that I was describing before, some pretty print statement. I might decide to call this function make a choice. So after the word def, I put that name, whatever I decide to name it. And the one important rule here is that much like a variable, you can't put a space in it. It has to start with text. It can't be all numbers. But whatever name you put, that goes right after the def word. And then at the end of that line, you put a pair of parentheses and a colon. So this part is different slightly language by language, but in Python, we use that colon to say, okay, that's the end of the naming part. I'm ready to start giving you those instructions. And in Python, in order to say, hey, this is part of this group of instructions, this is part of my make choice procedure that I'm describing here, we indent every line that's part of that function. So in general, this idea of indenting creates what's called a block of code. And in Python, any sequence of instructions that you write line by line that have the same level of indentation are part of the same block. So here I have these three, this print statement, this variable assignment, another print. If those three are all indented, like let's say I pressed space 4 times at the beginning of each line, then all 3 of those lines would be part of this make choice function. And once I'm done describing all of the lines of the function, then usually I'll press enter twice, give myself a little bit of blank space, and then stop indenting. Go back to having my next instructions be right up against the left edge of my window. So that's how we declare one of these functions, how we define that there is a thing called make choice. One important note here is that in our function here, this description we've made, we're only describing how to do something. By itself, that doesn't do anything in our program. If I just ran a program with my def make choice and nothing else, nothing would happen. If you actually want to do your function, then you have to call the function. And the way that we do that, like we said just before, is putting the name followed by a pair of parentheses, just on its own line or as part of an expression like the right side of an assignment. So if I wanted to use this make choice, instead of copy pasting the whole thing over and over and over again, all I would do in each of my places I want to use it is just write the name of the function make choice and then put a pair of parentheses right after it. So that is the basics of functions, how to write them and how to call them. What I want to do now is show you some of the fancy flourishes we have when we're using functions. So the first one of these is that we can pass in additional pieces of information to our functions, what are called function parameters. So the motivation behind this is sometimes we end up writing a function that works almost the same every time, but there's a slight difference. So a great example of this is, let's say I had a function to take the average of 2 numbers. I wouldn't want one function for the average of 5 and 10, another function for the average of 2 and 7, another function for the average of 3 and 12. The work I'm doing is basically exactly the same every time. I'd have to add them up and divide them by 2. So instead of writing a new copy of the function for each of these, instead, when I describe my function, I can leave a variable as sort of a hole in my instructions, as an ingredient that the person using my function has to fill in later. And when I do this, then when I call the function, I have to actually supply that ingredient then so that Python can follow the instructions. So a great simple example of this, say we had a function like this one here, do greeting. I might want to be able to greet whatever user is using my program and tell them, hello, person's name. But I don't want a different copy of this function for Joe and Sally and Jake and every single name of every single person that could use my program. So what I can do is define a variable for the person. And this function parameter up here, it is a variable just like any other, except we never actually assign it a value directly. I don't say person equals anything. I just say, here is a group of instructions called do greeting. And in order to do greeting, you have to give me one thing. You give me the person. And that's what those parentheses are actually for when we define a function and then call it, is that's where parameters get set. So here in my do greeting, I've created this person parameter. In the rest of my function, I can use that variable as if it already had a value. I can say, hello person. And notice I never set equals. Person never gets assigned any value, but still this function will work when it runs as long as I send that value in when I go to use it. And the way that I do that is when I call do greeting over here in the rest of my program, I have to give it something. It can be a literal string, or it could be a variable with a string of text in it. But however I represent this, look at the way information actually flows in this program here. So in this program, I'd be running along, I'd ask the user for their name, and whatever they type in gets returned from this input into username. And on the next line, when I call do greeting, I put the username inside the parentheses there. When I do that, Python is going to jump from this line of the code all the way out to wherever that function is described, wherever I put that def. And so my information is going to flow from this variable all the way out into my person parameter here. And it sort of implicitly assigns it. So whatever the user typed was saved in username. Username got copied over to person. And then for the whole function, I can use it as person. Note, I could probably not use username here because this function might be in a completely different file. It might be earlier up in the file before the actual input statement. When you are in a block of code, like inside a function, the only variables you should try to use are the ones that are declared right in that function. So if I made a new variable here, it would be fine to use that. If I want to use one of these parameters, that's fine as well. But what I cannot do is use the variables from the rest of the program because those might not exist. But in my do greeting here, whenever it's finished, we get to the end of the function. And what's going to happen then is Python will jump back to where that original call site was, where we called do greeting, and then it will continue following along the program, all of the instructions that came after. So these functions, we said they're a way to repeat. They're also a way to sort of take a shortcut to another part of your code. A great analogy for this is sort of like those choose your own adventure books people sometimes read as children, where you read to the bottom of a page and then it says, okay, now go to page 57. When you call a function, you're sort of telling Python, okay, go to page do greeting, do all of that, and then come back here and we can continue on. So that shows us an example of calling and how these parameters can get used. The last thing I want to show you is a return from a function. So remember, we said when you call a function, the variables that live in this block here only exists right here, that this person is only accessible while we're in doGreeting, and at the end of doGreeting, it ceases to exist. I can't use person from outside the function, just like I can't use username inside the function. But sometimes we actually want something to come back. Maybe I have some complicated math I'm doing, like taking a square root or a cosine. I might actually want to use that number later on. That might be the whole reason that I was writing this function, was to calculate that answer. So if I have a function like that, where I get some final result for later use, I am allowed to copy one single thing out of my function and give it back to whatever called my function. And the way that you do that is with a return value. So let's slightly modify our example from before, our doGreeting. And now we'll still pass in a username that becomes this person parameter. But what we're going to do, instead of printing out inside my doGreeting here, I'm going to construct some greeting text. My job is going to be to create this greeting variable that holds the greeting that has hello and the person's name. So remember, we said variables made inside a function stop existing when that function is over. However, by writing a return statement, which I can do by writing the keyword return, and then whatever I want to give back, whatever number or text or variable, what that does is sort of like doing a parameter in reverse. Instead of copying data from where you came from into your function variables, instead you're copying this greeting variable and replacing the entire call with that value. So if we were watching this information flow now, then the user enters their name in the main part of the program, they get to this doGreeting, and when they do, that name becomes this person parameter. We do all of that and produce this greeting variable here. Once we get to the end of the function, this greeting gets copied back, replaces this entire thing, because remember, we said you can use a function anywhere you could use any expression, and this function's expression, that final simplified result of it, becomes that greeting text that was in that variable. So if we say assigned it here, then when we call our doGreeting function, that greeting text gets saved into this message variable here. And that really shows us the most common way that we use functions. Most functions, the reason that they're useful is that they take some inputs and they produce back some output. And the really nice thing about these functions is once we've written them, we don't even need to know how they work. It can be almost like a black box that sits over a conveyor belt. You feed all your parameters in on one side of the conveyor belt, all of that information flows into the secret machine, whatever this function is, however it works, and then out the other end of the conveyor belt is your finished result. And you might not know how to do something like take a square root in pen and paper, but it becomes really easy to say, oh, well, I know square root is a function that takes in a number and gives me back a much smaller number. Functions are a way for us to encapsulate and hide all of the messy details of how we do work by passing in parameters and receiving back returned values. And where functions really shine is that we don't have to write all of them ourselves. In fact, you've already been using some functions that come with Python. Even in this video, we've talked about the input function, which takes in a text to prompt the user, and it returns back whatever the user typed. That's why we're able to save input into a variable. We're able to assign it because when that function runs, it goes and does a bunch of complicated stuff with terminals that probably you would struggle to write. But you know what it takes in and what it gives you back, and so you're able to use it. And it turns out Python has hundreds of these functions. Some, like print, are always available, but more specialized ones, it doesn't want to pollute your code with all of these hundreds of extra functions. So Python leaves them unattached to your program, and you can optionally choose to say, yes, I want to use that function. And the way that we do that is with an import statement. So an import statement is really simple. You just put the word import, and then you put the name of where that function lives. And that goes at the very top of your file typically. If you want to be even more specific and you know the name of the function you want, then you can write from someplace import some functions. And once you do that, those functions become another thing you're able to use in your code. So I actually want to show you an example of this to really drive home using functions and looking at some of the functions that are out there. So let's cut over to our coding window. And over here, we're going to start by importing a couple functions from Python that'll be useful for us. So from the random library, let's import the random function. This function, if we play with it down here, from random, import random, every time we call the random function, it gives us a random number between 0 and 1. So you can see it gave us 0.127, 0.773, 0.942. That's really useful if we want to change our program up every time we run it. Another function I'm going to use is the floor function. So there's this module math that has a bunch of really useful math functions like square root and sine and cosine. What the floor function is the round down function. It says, whatever number you've got, I'm going to round it down to the next whole number. So if I have 4.5, floor takes that 4.5 and turns it into 4 and gives me back that result. So now I've got some functions to help me along the way. What I want to do is I want to write a new version of my random function. I want a program where I can ask the user, hey user, give me a low number, and then afterwards, user, give me a high number. Give me both of these, say a number between 1 and 10. And then I want to be able to use my random, but instead of giving me between 0 and 1 a decimal, give me a whole number between this low number and this high number. So this random function by itself can't do that. So what I'm going to need to do is going to need to invent my own brand new random function. So the way I'm going to do that is with our def keyword. And I'm going to say, the name of this thing will be get number between. And so my get number between, in order to do this, I need to know two pieces of information. I need to know what is the lowest number I'm allowed to pick, and what is the highest number I'm allowed to pick. So my function here is going to have two input parameters, the low and the high. The way I'm actually going to do this is with a little bit of mathematical sleight of hand. I'm going to say, well, if I can get a number between 0 and 1, then I can turn that into a number between 0 and 10 by multiplying it by 10, because 0.99 times 10 gets me to 9.9. 0 times 10 still stays at 0, so I can increase the range by looking at how far apart this low and high are and then multiplying my random number by that. So give me a range that is equal to the high minus the low. Give me that multiplied value, which is equal to call my random function, take that result, and multiply it by the range. So now I've got this multiplied value. And look, all of these instructions that I'm writing, they're indented inside so that Python knows both of these are part of this get number between. But now I need to do a little bit more massaging to get my number into a random number that's a whole number. First, I have to chop off the decimal place, because if I multiply, 4.723 by 10, I'm not going to end up with a whole number. So I can use that floor function to do that. Say the whole number version is my multiplied value. Take the floor of that, and that will be the whole number version. And then the last thing I need to do is actually shift this thing up. If I set a number between 1 and 10, well, right now I've got between 0 and 10, so I need to add this low value in to put it in the right place. So I can say my final answer is that whole number plus the low of the range. And now I've written a function that, given a low number and a high number, can give me a random guess between that low and that high. So now the last thing I need to do in my get number between function here is I'm going to need to give back that final answer. And the way that I do that is with a return statement. I say, well, when you call get number between, you give me the low and the high number, and then I give you back this answer variable. You'll get a copy of whatever number is in there at the end. So now I've written my function to actually use it, because right now if I ran my program, say I ran python functions.py, make sure it's saved. When I run it, I do a low number, I do a high number, and the program's just over. It doesn't do anything yet, because remember, I need to actually call this function. I need to say the random result is call get number between. So I put its name again, and then in parentheses, I put in the values for the parameters. I could hard code them. I could say, oh, we'll do this. In fact, when you're first testing your functions, I recommend to run your program quickly. You try it with just a few known values. But in our case, I want to use the two that the user gave me, this user low and this user high. And notice the names are different. Outside of the function, I'm using the names of these variables here from the main part of my program. Inside the function, I'm using the names low and high, the parameters that exist, because remember, I should only be using variables that are part of this function while I'm in this function. I shouldn't use anything from the main part, because I don't know when this function is running and what's available there. But now I've got this random result, so I can finish my program by saying your random number is the random result that you gave me. And there's going to be one more thing that trips us up here, one more useful thing to know about functions related to variables and the different types of information they have. So when I run my program now, it's going to tell me there's an unsupported operation between strings. So remember, when I type input from a user, this comes back to me as text. So it comes back as the text number 1, not the actual number 1. There are two functions that let us convert text to numbers and numbers to text. So once I get my text from the user, I'm actually going to call the int function on that input to convert what they give me into a number. And this shows us one other cool feature of functions, which is actually that you can wrap them around each other. And when you do that, Python will work from the inside out. It'll say, run this function, get me the result, run this function, get me the result. Now it's fully simplified. Now I can save it into this variable here. So I can use int on both of these. And then in the same way, when I get the number back from here, I can call string on that result so that I can actually print it out along with my other strings. But now that I've made that change, I enter a low number, I enter a high number, and my function actually runs. So if we think about the order that Python is running this, it does the imports, it describes this, but the first line that runs is 15 all the way down here. It stops and pauses and asks us for a low. It stops and pauses, asks us for a high. And then when it gets to 17 here, it says, oh, I have to go find these instructions. Take this, copy it into here. Take this, copy it into here. And only then does it run all of the code up top here. Only then does it actually get a random number and do the floor and do our addition and subtraction and multiplication. So it runs this line, then that line, then it jumps up and does all of these. And once it's done that, it comes back to where it came from and runs the rest of the program. So that shows us how functions can cause our instructions to kind of jump around. But now I've got something reusable, and every time I run my program, it's going to give me a different random number, whatever it decided between my 1 and my 10 in this case. You can see I got 5 and then 2 and then 8. And that shows us how functions allow us to break up large problems into small little bite-sized chunks where I can tear off one little piece of what I want to do, figure out how to write code to do that, and then give it a nice easy name so that when you look at the final program, it looks really intuitive, easy to understand, and you've sort of hidden all of the hard work away so that you only have to think about it when you're fixing that particular part of the program. So that's how we use functions in Python and how we can access all of the functions that come from Python that come built in to the language. So that is the second most used statement. If we say variable assignments are the most used, function calls either as part of an assignment or on their own line are the next most common. And now you're in pretty good shape. There are a lot of really interesting programs you can write. From here, we're going to start talking about control flow and some of the cool stuff you can do to actually make decisions, make repetition. So look forward to that, and I will catch you all in the next video.